To correctly interpret a graph means that you can connect the story with the graph, that you can look at the axis, see what they are representing, and notice when the graph is going up, when it flatlines, when it's going down, and you can explain what that means in real life. So let's take this story. Jenny leaves home and drives to the beach. She stays at the beach all day before driving back home. Which graph best represents, or I'm sorry, shows, and I didn't spell right, did I? Shows the situation. Go ahead and pause the video, and I want you to copy down this paragraph because we're going to mark some things in there. So when we are matching the graphs, we want to look at the axis. They're each showing the time compared to Jenny's distance from home. So we need to see where it's starting from. These two graphs are starting at zero time and 0 distance from home, where this one is starting up really high, meaning that she's very far from home starting off. So if you go back to your story, she leaves home. So home is where she is starting, which her distance from home would be 0. She drives to the beach. So as she's driving to the beach, she's getting farther and farther away from home. So we've ruled out this one. This one cannot be the graph because she's starting a long way from home. So she drives, and while she's driving, that takes up time. She gets to the beach. So that would show the first point on each of these. She stays at the beach all day before driving back home. So if she is staying there all day, that means time is elapsing, time is going on, but her distance from home should be remaining the same because she's at the beach. With the first graph, that would be that she drove to the beach, she turned right back around and came home. Where the second graph, she goes to the beach, she stays there, so time goes on, her distance from home remains the same, and then she drives home and has an ending point of 0 because she's ending at home. Therefore, this middle graph best represents the situation. So let's kind of organize the thoughts that we had matching that situation with the graph. So some key components to interpret. First, that you understand the axes, that you look at the x-axis, you look at the y-axis, you see what it is that they are representing. And almost always time would be the x-axis. Not all x-axis represent time, but if time is part of the graph, then it will be the x-axis. You want to see the starting point and the end point. In our previous example, Jenny started at home and she ended at home. Therefore, her distance from home was 0. You probably noticed that those graphs didn't have tick marks to show specific distances. It was more of a sketch of a graph, but you can definitely tell where 0 is. You want to pay attention to flat sections. Jenny stayed at the beach all day, so that was a flat section on the graph. And changes in steepness, where it increases or where it decreases. So let's practice. Go ahead and again copy this paragraph. Pause the video so that you can copy this paragraph. Derek and Austin traveled 10 miles from Derek's house to the movies. They watched a movie and went 5 miles farther to eat lunch. After lunch, they returned to Derek's house. So the prompt is that you sketch a graph to show the distance from Derek's house compared to time. So I've drawn my graph. The x-axis is representing time. The y-axis is distance from Derek's house. I did put tick marks there because it tells that they traveled 10 miles to Derek's house and another 5 miles. So we've been given specific distances. So I went ahead and put that on the y-axis. Notice how I've pointed out key components of the graph. First, they went to the movies. They traveled 10 miles from Derek's house to the movies. So this communicates that their starting point is Derek's house. So their distance from Derek's house is 0. They go 10 miles, and that's when they're going to go to the movies. They watch a movie. So that's where it's flat there. Their distance from home is not changing because that's the time that goes on during the movie. And then they went 5 miles farther. So they went 5 miles farther out, so it increases from 10 to 15. They stopped to eat lunch. So this is another flat line. They ate lunch. Then after lunch, they returned back to Derek's house. And that goes all the way down. Now let's talk about how far that they traveled. If you wanted to calculate that, you could use the graph, because you could say going from 0 to 10 was going to the movies. Then they went another 5 miles to eat lunch. So that's 15. And then they went 15 miles back home. So their total distance traveled was 30 miles. Now you can practice this. Read this prompt and attempt to sketch that graph. On her way to the grocery store, a 6-mile trip, Veronica stopped to buy gas. After filling her tank, she continued to the grocery store. She returned home after shopping. So you need to sketch a graph to show the distance from Veronica's house compared to time, and then use that graph to find the total distance traveled. Okay, so here's my graph. She's starting at 0 because she's going from home to the grocery store. If you notice, I started to put additional tick marks, and then I corrected myself because it doesn't say how far into the trip she stopped to get gas. If I would have put tick marks, then I would be assuming a certain distance between her home and the gas station, and we don't know that. For all we know, the gas station could have been right in front of the store. So I just put it somewhere in the middle, and the only distance I know for sure is that in 6 miles she goes to the gas station. And actually, look at me, I did not label my axis. This one is distance from home, and that is in miles. And on the bottom is time. Okay, so she starts at home at 0 and then goes to the gas station. So this incline is showing getting to the gas station, her driving to the gas station. She stops to fill up. So there's a small flat line because it's going to take a little bit of time for her to fill up her tank. Then they go from she goes from the gas station to the grocery. Now she's at the grocery, 6 miles from home. She shops at the grocery, so that is a piece of time. And during that shopping, she's not getting any closer or far away from home. And then she drives home after that. So the second part, use the graph to find the total distance traveled. Like I said, I don't know exactly how many miles it was to get to the gas station, but I do know to the store was 6 miles. There was no more distance here, and then there was the returning distance of 6 miles. So it took her 12 miles.